So section 4.4 covers the mean value theorem. We're going to talk about the mean value theorem and Rolle's theorem, and we're going to have a good time. So Rolle's theorem says, let f be a continuous function over a closed interval ab, and it's differentiable over that interval such that f of a equals f of b. Then there exists some c between a and b such that f of c equals 0. Okay? So what this Rolle's theorem states is that if the outputs of a differentiable function are equal at the endpoints of an interval, then there must be an interior point where it changes directions, right? Here we see, if we look at a parabola, here's kind of a scooted over cubic, right? That it changes directions. And my output is equal at this point and this point. So at some point it must have changed directions, okay? Now, you might be saying, what if there was a straight line? Well, remember, a straight line on any point, a straight horizontal line, would be 0 anyways. So, not super exciting. Because f prime of c gives us the slope, because it's the derivative. So, let's take a look at an example. I have x squared plus 2x over negative 2, 0. So, f of x is a polynomial, right? We know that. It's a quadratic polynomial. It's differentiable. It's continuous. Let's find f of 2 and 0. So f of negative 2 equals 4 squared minus 4, which is 0. And f of 0 equals 0 squared plus 2 times 0, which equals 0. So now I have my endpoints, right? A and B, and they're both equal. Thus, there exists some c in this interval such that f prime of c equals 0. So why don't we go ahead and do that? I need to take the derivative of this function. So f prime of x equals 2x plus 2. And I can pull out a factor of 2, that's exciting. And I can set this equal to 0. So f prime of c equals 2 times x plus 1, which equals 0. So that means that my c right here, it has to be negative 1, right? X plus 1, if I set equals 0, I get x equals negative 1. So negative 1 is the point where it changes directions. Let's go ahead and clear what we've done here and do another example. We'll change to green. That sounds fun. So I have f of x equals x cubed minus 4x. This is a polynomial. It's continuous over the entire domain, right? That means it's differentiable. So let's go ahead and take f of negative 2 and f of 2. So f of negative 2 would give me negative 8 plus 8, which is 0. And f of 2 would give me 8 minus 8, which is also 0. So I know that there's some point c which exists. So I'm going to take the derivative of my function, f prime of x, equals 3x squared minus 4, and I'm going to set this equal to 0. I'm going to solve. So I have 3x squared equals 4. Divide both sides by 3. Then I take the square root of both sides. So I get x equals plus or minus the square root of 4/3, which is plus or minus 2 over the square root of 3. So I have 2 points in here. I have negative 2 square root of 3 and plus 2 square root of 3. Because this is a cubic, you know, we're kind of shaped like this, or this, depending. So negative 2 over square root of 3 is going to be my local max. If I plug that in, and positive 2 over square root of 3 is going to be my local min. The mean value theorem tells us this, right? Rolle's theorem is a special case of the mean value theorem. So in the mean value theorem over an interval AB, what's different here is that f of A doesn't have to equal f of B, right? It can have a slope. F of A doesn't equal f of b. That's why Rolle's case is a special example. So the mean value theorem states that if a function is continuous over a closed interval from a to b and differentiable over that function, over that interval, then there exists a c and a of b such that the tangent line of f at c is parallel to the secant line connecting f of a and f of b. So what it's saying is there, if I have 2 points, then there's got to be some point on this interval where the secant line, right, is parallel, so they have the same slope, to the line connecting these 2 points. So this point here is bf of b, and this point here is a f of a. Here's a corollary of the mean value theorem. Another corollary is the constant difference theorem, and increasing and decreasing functions. So this just talks about negative and positive corollaries, specifically for positive slope and negative slope.